Hello everybody. We are going to talk about multiplying and dividing rational expressions this evening. When we multiply or divide two rational expressions, the algebra that is used is simply an application of normal fraction manipulation. The following exercise will illustrate manipulation using a numerical fraction. So consider the product 15 over 2 times 10 over 21. The first step is to write all numerators and denominators in the problem in prime factored form. So 15 is 3 times 5. 2 is already prime, can't be factored. 10 is also, well, 10 is 2 times 5, not also. And 21 is 3 times 7. Now we're going to simplify this product by writing it as the product of two fractions, one of which is equal to 1. So we want to cancel out the 3's. We want to cancel out the 2's. And this becomes 5 over 1 times 5 over 7. Neither one of them is equal to 1, so I don't know what that part is talking about. 5 times 5 is 25, and 1 times 7 is 7. You're just multiplying straight across. So there is that example. Let's look at exercise 2. It says, now consider the product x squared minus 25 over x squared minus 1 times 4x squared minus 4x over 2x plus 10. Part A says write each numerator and denominator in factored form. So the numerator is the difference of two squares. Yes, Put-Put, the dog is barking. Since we have the difference of two squares, notice the square root of 25 is 5, so we want x plus 5 times x minus 5. The denominator, x squared minus 1, is also the difference of two squares. So we want x plus 1 times x minus 1. Now on the second fraction, we can factor out a 4x. So 4x times x is 4x squared. 4x times negative 1 is negative 4x. The denominator, we can factor out a 2. 2 times x is 2x, and 2 times 5 is 10. Now we can start canceling things. So x plus 5 will cancel with x plus 5. X minus 1 will cancel with x minus 1. 2 goes into 4 twice, and 2 goes into 2 once. And that is all we can cancel. So we end up with 2x times x minus 5 over x plus 1. So this is in simplest form. All right. Let's look at exercise number 3, part A. We can factor a 3 out of the numerator on the first fraction. So 3 times y minus 2. In the denominator we can factor out a 6. So 6 times y plus 2. Y squared minus 4 is the difference of two squares. So this will be y plus 2 times y minus 2. Y squared minus 5y plus 6. We need two numbers that have a product of 6 and a sum of negative 5. So we need negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. Now we can begin canceling. Y minus 2 cancels with y minus 2. Y plus 2 cancels with y plus 2. 3 goes into 3 once. 3 goes into 6 twice. So now we can write our result, which is y minus 2 in the numerator. The denominator is going to be 2 times the quantity of y minus 3. Let's do example B. For the numerator on the first fraction, we need two numbers that have a product of negative 10 and a sum of negative 3. So we need 2 times negative 5, which is negative 10, and 2 plus negative 5 is negative 3. There's nothing we can do to factor the denominator. The numerator on the second fraction can't be factored. In the denominator on the second fraction, we can factor out a 5. So 5 times x is 5x. 5 times negative 5 is negative 25. So there's our factorization. We can now cancel x minus 5 with x minus 5. With the x's, 3 minus 1 is 2. Since there are more x's in the numerator, or excuse me, in the denominator than the numerator, then we're going to keep x squared in the denominator, and this cancels. So we're left with x plus 2 in the numerator and 5x squared in the denominator. Let's look at the other side. Recall that multiplication and division are inverse operations. Because of this, division by a given fraction can always be accomplished by multiplying by the given fraction's reciprocal. Fill in each of the following sentences with the correct rational number. Dividing by 2 is the same as multiplying by 1/2. Dividing by 3/2 is the same as multiplying by 2/3. Division of rational fractions, or excuse me, division of rational functions follows this general idea. It is oftentimes summarized using the mnemonic stay, change, flip. I like to say keep it, flip it, change it. Some people like to remember it by Kentucky Fried Chicken. Keep it, flip it, change it. So for 8 over 27 divided by 20 over 9, we're going to change that to 8 over 27 times 9 over 20. Now we want to factor everything into prime factors. So 8 is going to be 2 times 2 times 2. 27 is 3 times 3 times 3. 9 is 3 times 3. And 20 is 5 times 2 times 2. So we can cancel a 2 with a 2, another 2 with another 2, 3 with 3, and 3 with 3. We end up with a 2 in the numerator and a 3 and the 5 in the denominator. So 3 times 5 is 15, and our final answer is 2 over 15. Part C in exercise 4. We want to factor the numerator and the denominator on both fractions. So 21, actually, excuse me, first we want to keep it, flip it, change it. So that's going to be 21x over 20y times 5y over 3x. So 21 is 3 times 7. So 3 times 7 times x is that numerator. 20y becomes 5 times 2 times 2 times y. And 5y over 3x is already prime. So now we can cancel 3 with 3, 5 with 5, x with x, y with y. We are left with 7 over 2 times 2, which is 4. So our final answer is 7 over 4. Okay, let's do exercise number 6. Find each of the following quotients in their simplest form. So part A. Remember, we want to keep it, flip it, change it. So we are going to take, let's see, let's go ahead and factor this. 2 times x minus 1 over 3. And then we want 9 in the numerator, so 9 x squared minus 1 in the denominator. And that becomes, notice this is the difference of two squares, so that's going to be x plus 1 times x minus 1. We can cancel x minus 1 with x minus 1. We can cancel 3 with 3. And we are left with 2 times 3 in the numerator, which is 6. And x plus 1 in the denominator. Alright, so that's our final answer for A. Part B. Let's go ahead and we'll keep it, flip it, change it first. Hopefully I didn't confuse you with the last example. Alright, let's factor everything. X squared minus 4 is the difference of two squares, so we need x plus 2 times x minus 2. In the denominator here, we need two numbers that have a product of -10 and a sum of 3. So that will be x minus 2 times x plus 5. We're going to multiply that by this fraction. X squared minus 25 is the difference of two squares, so we can just write that down as x plus 5 times x minus 5. In the denominator, we can factor out a 3. So this will be 3 times x, which is 3x, 3 times -5, which is -15. Now we can cancel. X minus 2 cancels with x minus 2. X minus 5 cancels with x minus 5. X plus 5 cancels with x plus 5. And we're left with x plus 2 over 3. Let's do part C. Okay, let's go ahead. Let's factor this numerator. So we're going to factor out a 5x squared. We have to multiply that by x plus 2. In the denominator, we need two numbers that have a product of -3 and a sum of -2. So we want x plus 1 times x minus 3. Now this denominator, we're going to put that in the numerator. Notice it's the difference of two squares. So this is going to be x plus 1 times x minus 1 over 10x squared plus 20x. We need to factor out let's factor out a 10x. So 10x times x is 10x squared, and 10x times 2 is 20x. Now we can begin canceling. X plus 1 cancels with x plus 1. X plus 2 cancels with x plus 2. 5 goes into 5 once. 5 goes into 10 twice. There are more x's in the numerator than the denominator, and 2 minus 1 is 1. So we're going to get rid of this x, and we're going to get rid of that exponent. So we end up with x times x minus 1 divided by x minus 3. Let's put the 2 in front of that. 2 times x minus 3. So that's your final answer on that one. The final example. In that first numerator, we can factor out a 3. So 3 times x plus 7 divided by, we need two numbers that have a product of -28 and a sum of 3. So it's going to be x plus 7 times x minus 4. This denominator is going to go in the numerator because of the keep it, flip it, change it. Notice it's the difference of two squares. So we're going to write x plus 4 times x minus 4. The denominator is going to be x squared plus 12x plus 32, but we need to factor that. We need two numbers that have a product of 32 and a sum of 12. Eight times 4 is 32, and 8 plus 4 is 12. So that's how we factor that. We can cancel x plus 7 with x plus 7. We can cancel x minus 4 with x minus 4. We can cancel x plus 4 with x plus 4. And we are left with 3 divided by x plus 8. All right, we'll see you tomorrow and we'll get some work done then. Talk to you later. Bye-bye.